Hey everyone, welcome back to this Developing with OpenXR series. Today we'll focus on extensions and add extension handling to the demo app that we've started on the last video. If you want to pick up where we left off, let me just show you. From the OpenXR Provider repo, you can just click on tag and you should see 01XR Instance XR system. This is the exact state of code where we left off from the last tutorial. Alrighty, so looking back at the helicopter view of an OpenXR environment, we know that the OpenXR extensions can be implemented by either runtimes or API layers. In the last tutorial, we created an OpenXR instance and provided our app name and version number, as well as the engine name and version number and API version. Today, to inform the runtimes of the extensions that we wish to use, we'll provide it with a list of extension names. But before we get knee-deep into the code, it's useful to understand what extensions are and how they actually fit on the overall spec. One way to look at the OpenXR spec is that it's divided into two main portions. First, we have the main spec, and second, we have extensions. For the main spec, it defines the key behavior that all runtimes must follow. This is enforced by conformance test code that vendors can run against their runtime. While extensions, on the other hand, are optional functionality that runtimes can implement, such as hand and eye gaze tracking. Keyword here is optional. So applications should add backup behavior if it's run on a runtime that doesn't implement all the extensions they want. So how do we know which extensions are supported by which runtime? Answer is your code should check and act accordingly. I'll show you how to do this exactly on our demo app later on. But if you just want to have an up-to-date snapshot of extension runtime support to guide your app design, Khronos does publish an extension support matrix. From here, you can see a list of extensions against the runtimes that support them. You might notice that extension names, they have these capitalized designations right at the beginning of the name. So what are they and what's the significance of these 3 to n number letters? They indicate the extension type of which there are broadly 4. First, we have Khronos extensions designated by the letters KHR at the beginning. These are extensions worked on by the entire working group and they came to a consensus on this spec. So it goes through the Khronos board for ratification and is covered, more importantly, covered by the Khronos intellectual property framework. So companies do have a set period to raise any IP concerns. From memory, it's around 30 to 60 days. And samples of these are the graphics extensions that are required to create the OpenXR instance. So we have Vulkan, DX12, and OpenGL, as well as other graphics APIs. We also have like the vismask and binding modifications as Khronos extensions. Another type is multi-vendor extensions. So they have the designation EXT at the beginning of the name. So these are typically worked on by a couple or more vendors writing and collaborating on the spec. There's no working group ratification or approval by the Khronos board required for this. And consequently as well, there's no IP protection for the multi-vendor extensions. Samples of these are hand tracking, the palm pose, and eye gaze interaction. A third type are single vendor extensions. So this is worked on pretty much by a single vendor who has full reign on writing the spec. There is no working group or ratification as well required by the Khronos board, and there's no IP protection as well. So examples will be the Facebook or Meta display refresh rate, HTC via Focus 3 controller interaction to be able to use the Focus 3 controllers. All of the functionality, rather, of the Focus 3 controllers. Now, one thing to note is that single vendor extensions doesn't mean that only a single runtime can implement this or implements this. For example, the FB display refresh rate is very useful, and it's actually implemented by at least 3 or 4 conformant OpenXR runtimes. Lastly, we have what we call experimental extensions. So this can be single or multi-vendor extensions, and they have an X right at the end. So EXTX or let's say HTCX. So what are these experimental extensions? They typically mean that the vendors aren't quite clear on a best practice approach for a particular functionality, but they do need to have something out there in the public domain to gain feedback and or experience for that functionality. So samples of these are the XR overlay extension as well as the Vibe Tracker extension. Alrighty, so let's apply all of that knowledge into our code. First off, let me just do a bit of housekeeping here. I'll define an app name because we'll be doing a lot of logging on this session. There, add it as a log category as well. All right, so what do we need to do? First, we'll need to create an OpenXR Provider object because we'll be using that for filtering out the unsupported extensions. Then we'll define a list of extensions that our app needs and filter that list of extensions with from the extensions that are supported by the currently active runtime. Next, we'll define the OpenXR instance and actually create the instance. All right, so now we'll list all of the enabled extensions just so that we can see what extensions were actually enabled by the runtime, kind of like an audit. All right, so we've created the provider there, and for the list, we'll use a vector. So vec requested extensions, and the strings are handily in the OpenXR SDK. So we'll just use Vulkan enabled to extension name. We'll add vismask as well. What else? Let's add an FB1, display refresh rate, as well as a valve1, analog threshold. That'll do. All right, so you might notice that we are enabling a graphics extension here while we didn't need to do that on the first demo. Reason is the OpenXR Provider did that for us, and I'm just adding it here for completion. All right, so now we filter out the unsupported extensions. And we're going to be using the OpenXR Provider, which is pretty nifty. And finally, we'll add the filtered out list into the application instance struct. So we need all these. All right, so now let's do a log of all of the extensions that have been enabled so we can capture that from the OpenXR Provider. And let's do the same thing for our list, our initial list, just so we can do, we can verify that we're doing everything correctly. So let's output to the log the extensions that we actually want. So this just needs to change to vec requested extensions. So I do const var, so that's good. Then after filtering out, let's do the same thing so that we can see what happens to the list after the filter. Alrighty, so that's it. All we need to do now is run this baby. So set it as a startup project and run. Cool. All right, so let's have a look. So we've got all of our lists in there, and you'll notice these are the ones that will be enabled. There's no valve analog threshold because I'm using the Oculus runtime at the moment. And you could see those are the extensions that are going to be active, that are active. Alrighty, so that's how you handle extensions with OpenXR, or the OpenXR Provider in this case. If you want to see how all of the filtering is done, it's relatively simple. So you could just go to the provider.cpp and just go to the helper functions that we've got here and just have a look. All right, in the next video, we'll be looking at creating the OpenXR instance in Android. There's a bit of one or two extra steps in there, and we'll cover that in the next video. All right, see you then.